Okay, second half of section 4b. Only going to cover a couple problems on this video, and then we'll pick it up on the next video. We'll get the remainder of this tomorrow. Find the slope of the curve at x equals a. All right. I could actually, the temptation is to do this. Limit as h approaches 0 of f of x plus h. Don't put it down yet. But I could just use a and a plus h. It's a value, but we're gonna get to that. I'm gonna come back and talk about that in the coming day or two. But I'm gonna go ahead with our comfort zone right now. I'm gonna use x plus h. F of x plus h, if we define this to be f of x equals y equals x squared plus h, f is a factor that takes things and squares them. It takes all of x plus h, squares it, adds 2. And what are the next two things I'm going to write? Minus parenthesis. You don't. There's times you don't have to, but it won't hurt to have a parenthesis around a monomial. It will hurt not to have a parenthesis around a binomial or beyond. Okay, minus f of x, x squared plus 2. Is that right? All on h. So I've got the limit as h approaches 0. Do I have to write that every time? Yep, you do. You do. It gets tiresome. You have to write it. Maybe get a little tiny rubber stamp and just it does limit h approaches 0. Okay, I get x squared. You know what I know right now? Somewhere out there I'm going to get a negative x squared because this doesn't have an h in it. Everything that is not an h better get canceled. So if I didn't put the parentheses there and I got a 2 plus 2, 4, I made a mistake because it doesn't have an h. All right. As I FOIL, I'm going to get an xh and another xh plus 2 xh's. That might not cancel because it's got an h. And I'm going to get an h squared. That might not cancel. But this 2 is going to cancel. That x squared is going to cancel. And that minus 2 is going to cancel. Pretty good mindset to have going into this because you're going to catch your mistake when it happens and you're not going to get 5 more steps down the road. Okay, so limit as h approaches 0, what happens? X squareds cancel, 2's cancel. H now divides out of every term. So I get 2x plus h. And now I can direct substitute. F prime of x equals 2x plus 0. Those of you who took honors pre-calculus last year, didn't we already know that? Kind of frustrating because it's like, when do we get? You'll get to soon. Soon we'll get to shortcuts on it. But right now we're going to show it and show it and show it. Did I talk to you guys about ad nauseum this year? I did last year, I think. Ad nauseum is Latin. Nauseum is probably exactly what you might think it is. Nauseous. It means until you're sick of it. So you're going to do this probably ad nauseum, and some of you are probably nauseamed already. All right. So anyway, we want to know what happens at a. So we want f prime of a. Well, f prime of a, if f is a factor that takes things, multiplies them by 2, I get 2 times a. And that's it. So I'm saying, we could have just started with a here. Watch this. And if they wanted to know the slope at 3, the slope is 6. But I could have just started with 3 here and here and specifically got 6 that way. But it's one tiny itty-bitty additional step to find out the slope everywhere. So I'm a big fan of just finding the derivative, the whole derivative formula rather than an individual value. But we'll practice some individual values as well. So then what does it say? Well, I know this curve looks like this. We have specialized in these things. You wanted to play parabolic charades? There it is. Jump up in the air twice. All right? So what happens is it says as A changes. Well, as A goes to the, let's go, as A goes to the right of 0, As A changes, what happens to the tangent? What's happening to that tangent line as I move to the right of 0? The tangent slope increases. You say something like that. What happens as it goes to the left? It is negative and decreases. We're not looking for exact words here, just some observation. As we move to the left, or I guess we could say from the left to the right, as tangent moves from left to right, the slope is constantly increasing. When it hits 0, it's 0. You know, a lot of things we could say about it. With me? Okay. Same thing. Again, I could just use A. If I was trying to find the slope at 3, I could just use 3. F of 3 plus h. We'll call this f of x again. So, limit as h approaches 0. F of x plus h. This is a factory that puts things right there. The 1's going to be here, the over's going to be here, but not x. It's going to be x plus h. This minus 1's going to be there. Minus, the next thing I'm going to write, parenthesis, 1 on x minus 1. Oh man, I wasted all that time, I didn't need it. You know what I'm saying? Just put it there. Just go minus parenthesis. All on h. Well, we've done this. Least common denominator, I need an x minus 1. I need an x plus h minus 1. But I can only multiply by 1. Who's my biggest offender? This guy. Gotta go. Limit as h approaches 0. Gotta write it? Yep. Distribute the whole thing. X plus h minus 1 cancels, and I get 1 times x minus 1. Minus. Distribute the whole thing to here. The x minus 1 cancels, and I get minus 1. Still, all to be multiplied by x plus h minus 1. All on h times x minus 1 times x plus h minus 1. Can I cancel the x plus h minus 1? Looks like it. Temporarily, this is a factor, but it's a factor of that term. Can't cancel it. What am I expecting to happen up in the numerator? Anything that does not include an h needs to go. Let's see, x minus x, right? Negative 1 plus 1, gone. What am I left with? Negative h on h times x minus 1 times x plus h minus 1. Or limit as h approaches 0 of negative 1 on x minus 1 times x plus h minus 1. And I've got rid of the big offender. So, direct substitution, negative 1 on x minus 1 times x minus 1. Once h is 0, and I've got negative 1 on x minus 1 squared. That is f prime of x. Could have been f prime of a, and I'd be done. Well, what is f prime of a? Negative 1 on a minus 1 squared. What happens? Well, do we know this? Do we know? Have we seen this enough now that we know what the curve of y equals 1 on x looks like? Haven't we? Put in 1, get out 1. Put in negative 1, get. We know that, right? So what does this graph look like? Looks just like 1 on x, except it is what happened to the asymptote? Went to the right one. Everything looks exactly the same, except it's to the right one. Looks just like this. So can we think of something to say about the slope as we go from left to right? Well, if we're to the right of the 1 and we continue right, the slope is negative, but it's approaching 0. You with me? To the right of 1, the slope is steep, negative, but it's flattening out. To the left of 1, the slope is flat, negative, and until we get to 1, it just gets steeper and steeper. So we can say something about the tangent lines in there. Is that all right? Okay, that's the only part of this. We will pick it up on this problem tomorrow.